Yeah, g'day YouTubers. Tinker O'Toole again here with another video. Today we're going to talk about chainsaw chain, the way that it elongates, it gets longer. Commonly most people refer to that as stretching, so we'll use that terminology, stretching, but the real reason is that the actual holes that are in the drive links and the tie strap and the cutters elongate. They get longer, especially between the front and the back rather than the top and the bottom. So most of the wear will be from the front and the back of the hole rather than the top or the bottom. Now there's a few reasons as to why that happens. One of the first ones will be a pretty obvious one, will be lack of oil. And it's just not the bearings and the tie straps and the cutters and the drive links that will suffer. The bar rail will, and your sprocket and your nose sprocket will also. So lack of oil is a bad thing. Now lack of oil could also mean that you put a large bar on it. You may have forgotten to turn up your oil adjustment if you have one. But in general, lack of oil is a bad thing. So that's one reason. Another reason is if you filed your rakers all over the place and you haven't been doing it properly, or you've been doing it too deep, the chain can start to cut a little bit erratic, meaning that it's not cutting nice and smooth. The smoother that it runs, the less jerking and pulling on the chain will minimise the wear rate. So if you filed the rakers a little bit deep and it's really biting into the timber and it's carrying on and the vibration will go up, you'll feel vibration more, and all that pulling and jerking is going to pull on these linkages between the front and the back, and it's going to elongate them more. It's going to wear at a much more higher rate. So that's another reason. Another reason also is that you should lower your chainsaw bar and chain onto the log nice and gentle. Don't do it in a sudden motion and cause it to be real jerky. If it's a real type of jerky action, does exactly the same thing. It pulls on all the linkages and jerks them, and it again contributes to abnormal wear. So when you do sink your chainsaw in, it's cold, it heats up, it cools. And that's another thing, when you put a new chain on, you're meant to sort of run it for about a half a minute or so and check the tension. Even though they say that they're pre-stretched, that just means that if they run the chain at the factory on a machine, it'll loosen up a little bit. The other thing that can contribute to high wear rates on a chainsaw chain, poor quality chain. Probably a lot of the stuff comes out of China is questionable. If you've got Stihl, Oregon, Carlton, Pro Cut, some of the better type brands out there will be much more durable, higher quality metal. Chains will last a lot longer, give you many more hours of cutting before they get too loose. And if they get too loose, you can run out of adjustment. Now, I went at great lengths to measure brand new the holes. So if we pull this apart and we're to measure the diameter of a brand new chain as opposed to one that's worn out, what I found out that between the front of the hole and the back of the hole has the greatest wear as opposed to the top and the bottom of the hole. So that goes on the cutter, the tie strap and the drive link. And the bearings themselves are exactly the same. So when you turn the bearings, when you push them apart with a chain breaker, you'll find out the top and the bottom has least wear, whereas the front and the back has greater wear. So that's where they all wear, between the front and the back rather than the top and the bottom, because of all that pulling motion. So the first chain that's got quite a lot of wear is a still RS chain here. And the difference between a brand new chain and this chain is that it's worn 11 millimeters in length per side. So if you're to break the chain open and measure the whole length of a 20-inch chain, it's about 1.340 millimeters in length. So it's 1.3 meters and 40 mil in length. Yeah, so 1340 millimeters. It's grown 20 millimeters in length due to all those linkages and wear, because you've got 72 drive links on a 20-inch chain, but you've got 2 holes each drive link. So multiply that is 144 holes. Then you've got, you know, the holes of the cutters and the tie straps as well. So they're all joined together and they all wear and they elongate. The worst chain that I ever saw elongated or stretched was a guy was using a 60cc saw, 20-inch bar, and he was cutting thick polyethylene pipe and thick PVC pipe. And rather than cut it and lowering the saw down nice and gentle, obviously he was lowering it down a little bit too fast, and the chainsaw's not meant to cut that plastic anyway. But there would have been a lot of vibration and jerking. And the vibration and jerking is going to pull really hard on these holes front and back and the bearings, and it's going to wear at a much more higher rate than it normally would. So again, if you file your rakers too deep and you've got a lot of vibration and it's jumping around, you're going to get a lot of abnormal wear. So we'll look at the first chain. It's a still RS chain. It's come to the end of the life. As you can see, there's not much yeah, but I can tell you what, you have a look at it, it's certainly done some hard work. So we'll just zoom in there a little bit. And you should be able to see the wear as I move that chain in and out. You can see that moving quite easily. So there's the wear on that chain, quite a bit, isn't there? And we'll just turn it around to a different spot. There's a different spot there. We'll pick this spot here. You can see that moving quite easily in and out, in and out. Especially the right. The right seems to have quite a bit of movement. So you can move up a little bit. Now the left one, you can see them, they're really moving. So this is what happens. That's worn actually quite a lot. It still actually cuts quite well, would you believe? Now this chain here is a steel chain. It's not RS, it's RM. Rapid Micro, which is semi-chisel. So it's a steel chain. Surprisingly enough, it's coming to its end of its life. It's got a little bit of life left in it, but not much. But there's virtually not much play in that chain. See, look at that. I'm moving my, not like the other one. I go to a different section. I'm moving my fingers in and out, and there's just bugger all movement. So they're 2 steel chains. Now, this is an Oregon semi-chisel. These are 3/8 chains too, by the way. You hold this one up. You can see that movement there. Oh. Go to a different section. Oh. Quite a bit of movement in that one as well. Not as bad as the first one. Now this is hurricane chain. This has come to its end of its life. But it doesn't have a lot of movement. Look, there is a little bit. Look. Not as bad as the steel chain. This is another hurricane chain, but this is semi-chisel. Very little wear in that. Elongate, very little elongation. Okay, So we've just shown you 5 chains, and the steel chain was the worst. But I think that was due to operator error rather than quality. And what I mean by operator error is making sure that you turn your oiler all the way up where it should be with the longer chains rather than the smaller chains. When you're lowering, especially in hardwood, when you lower the chainsaw into the timber, I know what happens. Once you get in the groove and in the moment there, you start to work really fast. And that's sometimes what can happen, that when you're lowering your chainsaw chain and bar down into the timber, sometimes you lower it a little bit too hard. You know, you rev up the chainsaw flat out and straight away you're into it. That sudden impact, the moment when the chain hits the wood, there's quite a bit of jerking action. It's that jerking action that actually causes a lot of this elongation. So if you can sort of just back off a little bit and just lower it a little bit more gentle, ease it into it, you'll find out that your elongation of your chain, the wear in the chain, will reduce if you just sort of take a little bit extra time when you're lowering into the timber. And that's pretty much it in a nutshell. So just to briefly recap, that all chains, it doesn't matter who you buy it from, where it is, they're all going to stretch, elongate. If you've got lack of oil, you haven't turned your oiler up, that contributes to a lot of wear, as well as bar and sprocket wear. If you lower your chainsaw bar and chain too aggressively into the log, because of that impact, that will pull very hard on the point of impact, and that helps to elongate as well. So try and be a little bit more careful, just lower it a little bit more gentle. The other thing that can help contribute to elongation, chain stretching, is if you file your rakers too deep. You'll find out that the chain runs a little bit rough, a little bit more vibration, there's more jolting, and that's going to contribute to elongation. If you can file the rakers at the correct height, you'll find out that the chain will run a lot more smoother, less vibration, less wear and tear on everything on the saw. So if you sort of abuse the saw, and let's turn around and say that you may be abusing the saw, but not intentionally. It's because maybe you got in the groove and you're working harder, and you know, you're putting the saw into the timber a little bit harder than you should. And all that jolting, so you just got to learn to back off sometimes and just take it a little bit more easy when you're using the power saw, when you're lowering it into the timber, that it doesn't sort of bang hit the timber and cause a lot of force on these bearings and the holes, because it just causes greater wear. Look, I hope that information helps. Thanks for watching anyway, and comments are always welcome. Bye for now.